Hey folks, it's time for chemistry. And lucky for you, I've got some helpers. So would you welcome from Mr. Henderson's class, Cheyenne and Emma.
Hey.
All right, we're going to work on percent yield today. It's our last thing for Unit 8. So,
Awesome.
you ready?
Yeah.
Okay, let's get started then. First, let's talk about yield. Yield simply means the amount of product that's made in a chemical reaction. That's all we mean. And that's why there's an arrow, right, that says yields arrow.
Oh, man.
I know, how about that? Okay, there's 3 types of yield to know about. So the amount that you actually get in the lab.
Actual yield.
Your actual yield. Right. Don't make it harder than it needs to be, right? The theoretical yield is what the balanced equation tells you should be made. If everything goes perfectly well,
Yeah.
right? And you do your lab exactly right.
We'll see
Which
how well
is
that works
not very
out.
often.
Right. And then there's such a thing as percent yield. And this is for those times when your lab doesn't go perfect, right?
Most of the time.
Most of the time. Right. So to solve this, we take the actual yield divided by the theoretical yield. And then, of course, that's a decimal, so we have to multiply it by 100 to get 100%, right?
Yep.
Okay, so in my very scientific terms, it's where you take what you got and you divide by what you should have got.
Oh, man, that's so scientifical.
Thank
Very
you.
complicated.
That's right. And then you still have a decimal, so change it to a percent, and life is good.
Sounds
Good.
good.
You think you can do that?
Yeah, I
Yeah.
can.
All right, I know you can. Clear my scribbles off the board. So percent yield is a measure of how efficient a reaction is, or sometimes it's a measure of how efficient the scientist is.
No.
Right? But usually a reaction has its limitations, and so like your boss would know that, and if you're not getting efficient yields, they're going to fire you.
That would
Oh, yeah,
suck.
you know.
Right.
Better
One
be
thing to
efficient.
realize, though, is that your percent yield cannot be bigger than 100%, unless there's something that contaminates it, because you can't get more than what you started with.
Yep.
Right? We can always get less, though. Theoretical yield will always be larger than the actual yield, because sometimes, like in the copper to copper lab, you might accidentally pour some of your copper down the sink,
Oh, yeah.
Yeah.
or
Yeah.
Yep. Like we did.
or some of it goes through your filter,
Oh, yeah.
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 or maybe some of it stuck to your beaker when you tried to pour it across.
Yeah, that happened too.
Yeah, lots of things, right? And so here's some other reasons. You might have impure reactants, like if your aluminum foil wasn't pure aluminum, right? Or competing side reactions. We definitely saw this when your aluminum foil reacted with the hydrochloric acid instead of the copper.
Yep.
Yep.
Yeah, that would reduce your yield. Loss of product in filtering or transferring. Yeah, we saw
Emma,
that.
no, I'm kidding.
Okay.
In the conclusion to your lab report, just put it was Emma's fault.
It was Emma's fault.
And in mine, it's going to say it was Cheyenne's fault.
Exactly. Hey, wait, Michaela's not here.
Oh, we can just
Yeah.
put it on
She
Michaela.
can't defend herself. Okay, so here's an example of what we do with this now. So we see this example. 6.78 grams of copper is produced when 3.92 grams of aluminum are reacted with excess copper sulfate. So this is pretty similar to the lab that you did. Right, we're trying to use the aluminum to displace the copper out of its compound and get our copper back. All right, so what is the actual yield? What did we produce?
6.78.
Yeah, 6.78. Okay, here's a tougher question. What's the theoretical yield?
13.89.
We
Boy,
threw
are
it-
you just making up a number? Yeah, Emma's right, but we're going to find out why.
I was like,
Okay.
Yeah, let's do TJ.
All right, so let's start with a balanced equation. We added aluminum to copper to sulfate. So how do those formulas look to you? Does that look right? Aluminum
I
is
think so,
good.
yeah.
And then copper 2 is the kind with a 2 plus charge.
Right.
Sulfate is a 2 minus. So
So
that
it just
formula
goes-
should,
yeah.
should be okay. But now when I have a single replacement reaction, this guy chucks out the copper. Copper's now by himself, and aluminum takes over as the partner for the sulfate. So now I'm going to crisscross my charge. Sulfate is a 2 minus, so I need 2 aluminums. Aluminum is a 3+, so I need
Three.
3 sulfates, yeah.
Awesome.
Okay, now our equation's not balanced.
We have to put a 2 before the CU, right? Something like that.
Something like that. Well, let's see. I have 2 aluminums, so let's fix that first.
Oh, wait, that's where it goes.
And then I have
Just
Get ahead of
kidding.
yourself.
3
Sorry.
sulfates, right?
Sorry.
So 3 sulfates I need to fix here. So fix your copper. How's that look?
Okay, that looks
Looks
better.
good.
Okay.
That's what I meant, you know? That's exactly
That's
what
okay.
I meant.
We all meant what you knew, so life is fine.
What?
Yeah.
All right.
So what was our starting place? What did we start with? This or this?
3.92 we started.
Right. Our reaction started with 3.92 grams of aluminum. And it says we had excess copper 2 sulfate. So excess means that's extra information. We don't have to worry about copper 2 sulfate.
Okay.
Okay. So how much copper should we make in this reaction? That's going to be our theoretical yield. And what's our first step always? When in doubt, what do we do?
Go to moles.
You got it. When in doubt, go to moles. And so aluminum is 26.98 grams. Oh, can't write. 26.98 grams per mole. That comes from the periodic table, right? So that was easy. And now moles of aluminum is on top, so I'm going to put it on the bottom in my next step. And I want to change it to moles of copper, so I'm going to need my balanced equation. How many aluminums are in my balanced equation?
2.
And how many coppers?
3.
Okie dokie. Now moles of copper is on top, so I'm going to put moles of copper on the bottom, and I'm trying to get to grams of copper. Remember, that was our goal all along. It's easy to forget. What were we trying to figure out? We're trying to figure out grams of copper, so I need to know how many grams are in 1 mole of copper. And that's on the periodic table, 63.55 grams. So my calculator person, Cheyenne, will multiply the top times the top times the top times the top all the way across. And then divide by what you get on the bottom. So divide by 26.98, and then hit enter, and then divide by 2.
So it's 13.85.
What a
Oh,
great.
Oh, man.
13.85 grams.
That was the greatest ever.
Okay, so that is our theoretical yield. That's what we should get if every single atom of aluminum reacts with every single atom of copper. That's what we should get. But we didn't. We got only 6.78 grams. So that question says, what is the percent yield? So we take what we got, and we divide by what we should have got. And then we turn that decimal to a percent,
Should be 48.9.
48.9%.
So this person is way off.
Right, so if your grade was determined by your percent yield, you
You'd
would
be-
fail.
yeah.
You'd be taking this class next year.
Oh, be horrible. All right.
You know you love this class. I'm going to keep you for next year just for that.
Okay, okay.
Okay, let's do one more. Because you might have to do something like this on your midterm. Hint, hint.
Oh,
Oh,
no.
man.
All right, so we have 52.29 grams of silver chloride that forms when 25 grams of magnesium chloride was added to 68 grams of silver nitrate. What is the percent yield in this reaction? That's
We
a
have to do
lot of
our-
information.
I'm not going to guess this time.
Okay, well, we do have a balanced equation. That helps,
Yeah, it does.
right? But I don't know which of these two is in excess. I don't know which one is my limiting reagent. So,
So we're going to have to do a T-table for both.
right. We'll start one T-table with 25 grams of magnesium chloride, and we'll start another T-table with 68 grams of silver nitrate. That way, when we get to grams of silver chloride, we'll see which one made the least amount, because we'll know that one ran out first.
Right.
So we might as well start with the first number they gave us. Wow, come on, Pin. Okay, when in doubt,
Moles.
go to moles. So, what's the molar mass of magnesium chloride?
It's,
Let's see, 24 plus
oh,
35.45,
95.21.
95.21.
Yep.
Thank you.
I'm sorry.
Magic molar mass person. Good.
I know it was there somewhere.
Okay, so now magnesium chloride's going to have to go down on the bottom because it was on the top before, right? And we want to change it to, what's our target? Silver chloride. I always circle my target and underline important information, and it's a habit. It's a good habit.
yeah.
Yeah, it helps keep me organized. So look at our balanced equation. How many MgCl2s? There's not a number there.
We have 2.
There's not a number there. It's just one.
Oh, I was looking at them both.
Yeah,
It's
I
all
was
right.
like-
It's okay. Now you know. Now we made a mistake so that our audience doesn't have to.
Awesome.
Good.
So
You're
the-
welcome.
So
Got
there's
you covered.
2
No big
of
deal.
the other one.
Right, silver chloride. 2 silver
That's the one I
chlorides.
was looking at.
Right. Okay, so now moles of silver chloride is on top. It's going to go on the bottom next. Moles of silver chloride. And for every 1 mole, how many grams of that do we get?
143.32.
143.32. So we just used the periodic table, right, and added up 1 silver and 1 chlorine. So now we're going to do the top times the top times the top, and then divide by what's on the bottom.
It's 7,166.
Wow, that's a lot more than what we actually got.
Yeah.
Way more. So I'm starting to think maybe magnesium chloride's not the limiting reactant.
Yeah, I don't think so.
Let's see what we get with silver nitrate. So 1 mole of silver nitrate weighs how much?
169.88 grams.
169.88 grams. Okay. And now silver nitrate goes down here, and we want to turn it into silver chloride. So look at your balanced equation.
It's 2 of each.
2 moles of each. Okay. Barely had room for my moles. Had to squish it in. All right, so now silver nitrate cancels. Grams canceled. I'm at moles of silver chloride, so I want to change moles of silver chloride into grams of silver chloride. No problem. We've found that molar mass earlier right here, right?
Yep.
Yep.
143.32. Okay, top times the top. Oh wait, let's cancel out the 2's, make our math easier.
Right.
Always look to cancel because I don't like doing hard math.
And
So
then
what do we
it's
get?
We get 57.36 grams.
57.36 grams of silver chloride. Yeah, that's more like it. That compares better.
it's a little bit closer.
Just
Right.
a little bit.
Right, so what we see here is that we could never possibly make this much grams of silver chloride because once we get to 57.36, now we're out of silver nitrate. We've
Right.
used it all up and we can't make any more. So that could not be. This magnesium chloride is our excess reagent, and then this silver nitrate was our limiting reagent. So this is our theoretical yield. And our question, back to the question finally, says,
Oh, man.
what is the percent yield? So we've done all this work and we still haven't even answered the question.
Oh, jeez.
Okay, remember what we do? Take what you got
52.29.
and divide by what you should have got.
57,
57.36.
57.36. And what percent is that?
91.2.
91.2%. Hey, that person had more skills than our last guy.
Oh, man.
Yeah.
Or girl. Don't want to be sexist or anything.
Oh, it was definitely a girl. I mean,
All right, so that's how we do percent yield. What do you think?
easy enough.
Yeah,
I
once you
think.
practice.
You know.
Yes, practice. That will help. All right,
Yeah.
that's it. See you guys.
Awesome.
Bye.